presented by the British Columbia Ministry of Forests. Welcome to this introductory tutorial for TIPSY version 4.2, presented by the British Columbia Ministry of Forests, Lands, and Natural Resource Operations. TIPSY stands for Table Interpolation Program for Stand Yield. TIPSY Forest Growth and Yield software has been used extensively in British Columbia for over 10 years. Version 4.2 can be downloaded free from the Ministry webpage below. The menu on the left appears throughout this tutorial. Use it at any time to move forward or backward to topics of interest. You can also pause or replay this video at any time. TIPSY is currently used in a number of forestry applications in BC. The most prominent being timber supply analyses supporting allowable annual cut or AAC determinations for public forest management units across the province. In addition to predicting future timber values, TIPSY also provides key stand structural characteristics used to predict other forest values such as wildlife habitat, biodiversity, and visual quality. TIPSY supports a wide range of silvicultural applications, including stand-level silviculture prescriptions, silviculture investment strategies, and development of stocking standards under the BC Forest and Range Practices Act. Beginning with version 4.2, TIPSY also supports biomass forecasts for biofuel potential and carbon capture estimates for carbon offset projects. TIPSY provides growth and yield predictions for BC's major commercial tree species, including 13 conifers and 2 broadleaves. TIPSY supports a number of common silvicultural practices, including a wide range of initial densities for both natural and planted stands, genetic gain estimates from BC's Tree Improvement Program, plus fertilization, pre-commercial, and commercial thinning estimates based upon field experiments. TIPSY can also be used to conduct economic investment analysis of these practices. TIPSY will also estimate the yield impacts of variable retention harvesting and windthrow. For those familiar with earlier versions of TIPSY, version 4.2 incorporates additional outputs for well-spaced trees in accordance with BC Regeneration Stocking Survey methods. 4.2 also provides estimates of juvenile wood, biomass, and carbon. New input capabilities include expanded options for fertilization and genetic gain, plus the ability to import files containing custom functions for fertilizer response and oats. Experienced users will notice the plotting program has been completely redesigned and renamed TIPSY. It provides greater functionality for graphing TIPSY output, and the economics and jobs modules have been updated with 2006 values. It's important to understand that TIPSY is not a growth and yield model itself. TIPSY generates report tables interpolated from its internal database of TASS output. TASS is the actual growth model behind TIPSY. TASS stands for Tree and Stand Simulator. TASS is the product of ministry collaborative research over almost 40 years. It's a unique biologically oriented model that simulates the growth of individual tree crowns and stems in 3 dimensions. This TASS-generated image reflects the actual level of 3D spatial resolution in the model. This includes spatial tree coordinates and crown dimensions. Crown growth and competition determines crown size, which then derives bole growth on an individual tree basis. This level of resolution allows TASS to simulate spatially complex silvicultural practices like variable retention. TIPSY provides easy access to TASS output, yet by necessity, TIPSY is less flexible and has fewer options than TASS itself. Now let's take a look at TIPSY itself. When I close the About window, a welcome box pops up which can walk me through all the steps to create a new TIPSY stand regime file. But before I demonstrate that, let's take a quick tour of the TIPSY menu and toolbar across the top. It functions like a typical Windows program with the standard menu options. TIPSY's extensive help section contains lots of background documentation, including definitions of terms, how fertilizer response is calculated, and how oats work. TIPSY help is also context sensitive. so clicking on one of the help buttons located throughout the program takes you directly to help for that specific location and option. The more frequently used menu functions are repeated as toolbar icons. Their labels pop up when you hover over them. You'll see most of the toolbar icons are gray and inactive until we create a TIPSY stand regime file. To get started, click on File, New, or use the first toolbar icon. Creating a new TIPSY stand regime involves 5 separate dialog windows. The settings in each one can be edited later. In this first window, you can enter your own project title. This will appear on all outputs to help you identify this particular stand regime. TIPSY uses the stand geographic information to determine localized costs for economic analysis, but this has no effect on site quality or growth. I'll just accept all these defaults. The second window is species specifications. These are all the species-specific options. This is where we can add and delete species. I'll delete the default pine and add Douglas fir. This list currently displays interior species based on the stand geographic information from the previous window. After selecting the species, the site index window pops up. TIPSY gives us several ways to change the site index. I can overwrite the default by typing directly over it, or use the slider. TIPSY can also calculate site index from age and height. Click on Help to explore this option in more detail. You can also change the site index equation that TIPSY uses for each species. Notice the default always has a star by it, identifying it as the ministry standard curve recommended for timber supply and most other applications. The drop-down menu lists other available curves, and the associated notes provide documentation. This same suite of curves is also found in the ministry site index software called Site Tools. If I add lodgepole pine as a second species, TIPSY uses its internal species conversion equations to estimate its site index relative to the first species. You can easily overwrite these estimates if you wish. TIPSY then asks for a species composition percentage for this second species. You'll notice the species specification table has been updated accordingly, and a note now appears explaining the limitations of multiple species use in silvicultural applications. TIPSY uses simple area-weighted averaging to calculate multiple species yields from its database of single species yields. This is commonly used in forest-level analyses for aggregate analysis units, but the absence of mixed species dynamics normally excludes its use in stand-level silviculture. Buttons are provided to edit species composition, site index, and stock height. Checking the box next to genetic worth lets you assign genetic worth estimates to planted species. Version 4.2 includes 2 new buttons which let you enter custom functions for fertilizer response and OFS. As always, you can click on Help to explore these options in more detail. Before moving to the next window, I'm going to delete the fir just to keep things simple. This third window is stand specifications, where we find options that apply to the entire stand rather than each individual species. This window is divided into 3 sections. TIPSY accommodates planted and natural regeneration using 3 spatial distributions. Planted consists of a square pattern with some minor random variations. Natural utilizes a totally random pattern. Natural is also available in a clump pattern for some species. These distributions can be visualized using the Plot Stem Map button. Delay refers to regeneration delay, which is the time lag between a stand replacement disturbance such as harvest and seedling establishment. I should also mention here that TIPSY does not account for natural ingress, and it assumes relatively favorable establishment conditions, which can be seen in the early mortality trends. TASS provides much more flexibility in both these areas. There are 3 ways to select initial density. Density and spacing outputs are linked. Changing one automatically changes the other. TIPSY always requires an initial density, but this is often unknown for existing stands. You can estimate an unknown initial density by approximating current conditions through repeated trial and error, or you may be able to use TIPSY's built-in calculator. Refer to help for more details and limitations. There are 3 treatment options: pre-commercial and commercial thinning plus fertilization. TIPSY restricts both the timing and density range for both types of thinning. For instance, in TIPSY, pre-commercial thinning always occurs at a 4-meter stand height in the interior and 6 meters on the coast. Fertilization response follows the response functions selected in the species specifications window. The timing and effectiveness of multiple applications can also be set here. Again, refer to help for details and limitations. TASS provides much greater treatment flexibility here as well. Finally, the Operational Adjustment Factors, or OAFs section, provides a number of options. First, let's look at just what TIPSY OAFs do. TIPSY OAFs are used to adjust yields for factors outside the scope of core model predictions. Although TIPSY provides many OAF options now, the traditional OAFs 1 and 2 remain the most commonly used OAFs. OAF 1 represents small, unproductive areas, such as small rock outcrops and wetlands, otherwise unaccounted for through mapping and previous net downs. OAF 2 is a simplistic surrogate for insect and disease impacts. In the absence of better localized information, these standard defaults are recommended. TIPSY also includes other types of OAFs, including OAFs based on research by the Canadian Forest Service for armillaria root rot. You can see in this graph that OAF 1 and OAF 2 behave differently. OAF 1 is a constant multiplier applied to yields at all ages. OAF 2 is an incremental multiplier indexed to base age 100. Its impact on yield increases over time. In this example, the OAF 2 of 0.8 increments annually by an amount equal to 0.8 divided by 100. Both OAFs are normally used in combination. Back in TIPSY, we see the 2 traditional OAFs and their normal defaults at the top. Beneath them are 3 checkboxes that activate other OAF-related options. Custom OAFs can be activated in both species and stand specification windows, enabling their application at either level. Decay, waste, and breakage applies the same standard ministry net downs found in VDYP, the ministry's growth and yield model used for unmanaged stands and timber supply analyses. Given the many OAF options here, care must be taken to avoid double counting their various effects. A number of variable retention options are provided, along with VR-associated wind throw predictions. Extensive documentation can be found in help. The 4th window defines table specifications for subsequent outputs. Volume and other output variables are normally reported by age, but can also be reported by top height. I'm going to reduce the steps to 5 to provide a bit more resolution for reports and graphs. This 5th and final window lets you select the details that appear in the stand description output. And this is what it looks like. File, Save, saves all the specifications defining a stand regime in TIPSY's own TIP file format. Opening a TIP file reloads all the stand regime specifications. File, Make Default sets the current stand regime specifications as your own custom defaults for TIPSY. This is very handy. Once a stand regime is created or loaded from an existing TIP file, TIPSY can generate many types of output. Before exploring these, let's take a look at preferences. Besides metric, TIPSY can report in imperial units. I always prefer to switch to single view. That way TIPSY displays only one output window at a time for each stand regime, preventing me from being buried under tons of windows. Now we'll use the yield sign icon on the toolbar to generate a standard yield table. Use this pop-up box to select volume utilization limits to be included in the table. After generating any of the various TIPSY reports, you can reopen and edit table specifications by clicking on the pencil icon. In this TIPSY yield table, age is the first column, followed by top height. Gross and total volume refer to the entire stem from ground level to the tip. Gross includes cumulative mortality and total is just live trees. Merge volumes omit stumps and tops. The plus number refers to the lower utilization limit in terms of diameter. Larger diameter limits take longer to produce merchantable volume. Mean annual increment, or MAI, is reported for each type of volume. After the last MAI column comes stand basal area, followed by DBHG, which is quadratic mean stand diameter. This represents the tree of average basal area. The last three columns are statistics for the largest 250 trees in the stand. This serves as a simple surrogate for stand value. In addition to yield tables, TIPSY provides a wide range of other reports. Moving to the right, the next toolbar icon generates stand and stock tables. A stand table lists the number of trees by diameter class, and a stock table is volume by diameter class. The next icon produces yield tables for lumber and chips. These were generated by bucking and sawmill simulators linked to the TASS output. The next icon produces log grade yield tables. The $ icon launches powerful economic analysis software linked to lumber and log yields. The next icon generates an employment yield table. The next three icons generate tables for mortality, snags, and coarse woody debris. The alphabet block icon allows you to format custom yield tables by selecting specific columns of interest. This is where you access outputs for biomass, carbon, juvenile wood, and well-spaced trees. The next icon generates a TIPSY yield table using VDYP's yield table format. The TS icon produces the yield table format most commonly used in ministry timber supply analysis. The stump icon generates a harvest summary report providing statistics on the optimal physical and economic rotations. The SE icon generates a report of silviculture events for the regime. Finally, the last icon launches TIPSY's batch processing routine to generate multiple yield tables to support forest level analyses involving multiple stands. Version 4.2 includes a completely redesigned plotting routine called TIPSY, which allows you to graph various TIPSY outputs and visually compare different regimes. To demonstrate this, I'll click on the toolbar graph icon to launch TIPSY. This first window is where you select the y-axis variables for your graph. I'll select merch volume 12.5. The x-axis is always going to be age, based upon the yield table format itself. And here's the initial graph. TIPSY provides a number of powerful editing tools that allow you to modify and format the graph. A number of these can be accessed through the Edit Graph Template button. Its three tabs let you edit practically all aspects of the graph. Let's graphically compare this unthinned stand with a thin stand. First, I'll need to create another stand regime and yield table. To do that, I'll minimize TIPSY and return to TIPSY. I can quickly and easily thin the existing stand through Edit Stand or the Stand Specs icon on the toolbar. I check the PCT box and then click the button to enter a residual density. The yield table is automatically updated to reflect the thinning. Now I'll use the Save As icon to rename this new regime. Then I reopen the original unthinned file and bring up its yield table. Then I send the thin stand to TIPSY. Now I see both the thinned and unthinned files under Data Source. I select them both, then select Overlay from the screen layout options. For this particular regime, it looks like thinning will reduce merchantable stand volume. But we also know thinning concentrates growth in the larger, more variable diameter classes. I can easily graph the two stock tables to see this effect. First, we switch both yield tables to stock tables by clicking the appropriate icon and selecting Stock Table Only. Then we send each one to TIPSY. Theme in this case refers to age, since two-dimensional stock table graphs can only display one age at a time. For this example, I'll select a common rotation age of 70. Select both files and overlay. Now I can visually compare volume foregone in the lower diameter classes to volume gained in the upper diameter classes. Of course, economics is the other story here. Was the cost of thinning justified in this case? That is a question for TIPSY's economics module, and a topic for a future tutorial.